Good evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to the Teleconnections Discussion for Friday, the 18th of November, 2022. On the front slide of this evening's presentation, showing what it looks like for tomorrow, the 19th of November, as far as temperature anomalies. This is the GFS 2-meter temperature anomalies in degrees Celsius. And as you can see, we have some anomously cold temperatures across the majority of the United States right now, from the Idaho, Montana area all the way across to the East Coast up to New England, all the way down the Gulf Coast, even northern Florida. We have below normal temperatures. And so we're in an anomalously cold pattern for sure. And let's go ahead and get right into the discussion tonight. First thing I want to start off with is looking at the 500 millibar height anomalies for the 18th of November 2022. And I want to take a look at the Northern Hemisphere and focus specifically on that as we now head in towards just a week prior, just slightly less than a week to the Thanksgiving holiday. What we're looking at, as I brief this from west to east, we start off with the upper level trough feature over Siberia, extending northward, generally northward to the Arctic Ocean. There's an upper level trough in this area here in the upper left portion of the graphic. Working our way eastward, we see an upper level ridge over northeastern China, and that is extending northward. Followed downstream by this upper level low, this cutoff low over the north central Pacific, with rising heights downstream of that upper level low. And that is associated with this major player or atmospheric feature that is partially responsible for the very cold air across the majority of the United States. And this is this huge upper level high, this closed high, which is situated there along the southeastern Alaska, northwestern Canada coastline. The center of this upper level high, some astounding pressure levels for sure up into Alaska this week, including some record-breaking 500 millibar heights also for the month of November up into Alaska this week. So we have this anomalous upper level ridge, and look how far north this thing extends, all the way up into the Arctic Ocean. And then basically in the atmosphere, what goes up must come down. And so downstream of that anomalous ridge, you see some much lower, anomalously low upper level heights at the 500 millibar level, and these green and purple shadings here indicating those lower heights for a good chunk of the United States. Working our way eastward, as we continue our way east, we see a upper level ridge parked across the north central Atlantic, and then downstream troughing basically to the east of that into parts of northwestern Europe. And then finally we see another anomalously high height center. This one's generally located over Norway into Sweden, extending northwards towards the Arctic region. And so we have two major northern hemispheric upper level high situations or blocking situations at the present time tonight. Looking at the Madden-Julian oscillation phases, this is just a review of where the enhanced convection is generally occurring, whether we're talking about MJO phase 1 all the way to MJO phase 8. And generally, for example, if we had enhanced convection or rainfall patterns in phase 1 there off the coast of Madagascar, if we were in MJO phases 2 and 3, we would see that convection and the enhanced rainfall across the Indian Ocean. Phases 4 and 5 of the MJO correspond to the maritime continent and increased convection at that location. And then phases 6 and 7, general Western Pacific convection or enhanced rainfall situation in those phases. And then MJO phase 8, two locations really, one off of the western coast of Africa, the other in the vicinity of the international dateline, which is represented by this 180 degrees west longitude line. So MJO plays a big role in the overall weather. It's a pulse that moves eastward within the tropical areas there from the Indian Ocean to the Pacific. So let's take a look at the IR infrared satellite imagery for the 18th of November 2022 for two specific regions of interest. The first here on the left is for the Western Pacific Ocean, and for the infrared satellite image, what we're doing is we're measuring the cloud temperatures. So the brighter the coloring of the clouds, that means colder cloud tops. The grayer, The duller grayer colors indicate lower clouds and warmer temperatures in general. And so what we got going on today, here the 18th of November, we do see some increased areas of convection or enhanced rainfall areas, generally just to the east of the Philippines, and then also into the South China Sea there, to the west of the Philippines. We see a lot of increased cloudiness here in this area of the Pacific Ocean, the Western Pacific. We have our typical storm systems. You see the swirly nature to this particular satellite image. So we have a lot of mid-latitude storm systems cranking up, generally in the vicinity of 40 degrees north, and then you have these remnant frontal boundaries which extend southwestward from these areas, these deep areas of low pressure. Over here on the right, I have a IR satellite image of the Indonesia area, Indian Ocean in this location. And just we're moving our picture west from the image here. I show it on the bottom left, or the left here, with all this convection and the South China Sea. I'm just moving it further to the west so you can see what's going on over Indonesia. And there is a lot of scattered convection and thunderstorm activity across this part of the tropical area. Looking now at the Madden-Julian oscillation temperature composites for the months of November, December, and January. I will change these specifically when we get into the month of December, which we're not too far off from that right now. But generally, I just wanted to show you what MJO phases correspond with above or below normal temperatures for the United States. The blue coloring indicating below normal temperatures, the orange coloring above normal temperatures for the months of November, December, and January. These composites do not remain the same. In fact, when I show you a video here in early December, you're going to see the December, January, February temperature composites for the MJO phases, and it's going to be slightly different. All right, so generally this time of year, we have phases 7, 8, and 1. Generally cooler than normal conditions across, 7 and 8 across a large chunk of the United States, and then also phase 1. We get into phases 3 and 4, 5, and 6. You notice how much warmer things get across the United States, specifically phase 6 into the eastern U.S. Here's the forecast, the latest Ensemble GFS MJO forecast. What I want you to do is pay attention to this average mean line here, the green line. This indicates the forecast. Our starting point is right here, right next to the word start. And you can see that that green line is the average of all the members of the ensemble run. And so right now, the way things are looking, according to the Ensemble GFS or GEFS, MJO is forecast to rotate into phases 6 and then to 7. Now you notice some of these yellow lines here, they do indicate some turning or rotating back into phase 8 as we get into December. By the way, this diagram goes right on through the 2nd of December. One thing I did want to mention before I change slides is, this was looking more promising to go from 6 to 7 to 8, just 24 to 48 hours ago, and now we're kind of seeing a turning of the GFS ensemble, that green line, kind of rotating back towards the null phase, towards the end of the run as we get into early December. Here's the GFS operational forecast here on the left, and I want you to pay attention to this aqua color line, this light blue looking line here. Very similar. Let's go ahead and compare. This is a little bit more amplitude when we talk about the GEFS MJO forecast, a little bit further away from the inner circle, so greater amplitude or magnitude to the MJO, whereas the GFS keeps it closer to the null phase, weekly into phase 6 and weekly into phase 7. But you notice the abrupt left-hand turn on the GFS operational forecast for the MJO back to the null phase by December 2nd. Okay. And this is normal, when we expect MJO to be in phases 6 and 7, specifically in La Nina conditions, which we're seeing now, because you have warmer than normal waters that are across the Western Pacific. And above warmer than normal waters, you typically get rising air motion and some sort of convection and enhanced precipitation. So, where this is setting up, the MJO phases in 6 and 7 here between now and December 2nd, it's not a surprise. Looking at the climate forecast system, the CFS, 30-day forecast for the MJO. This also looked more promising for a few days this week. It showed the MJO rotating into phase 8 from the null to phase 8 and then over to phase 1. And like I showed you in the composites here, phase 8 and phase 1, those are colder than normal patterns, specifically for the eastern United States. And now look at the CFS forecast right on until the 18th of December. just briefly coming out on the edge between null and very weak into phase 1. So overall, the CFS forecast is now corrected to more of a null phase, which basically means that the MJO, if this were to verify, would not really have a significant impact on the overall weather in the United States. Looking at the sea surface temperature anomaly map, you can see La Nina sticking out very nicely here with the blue coloring here. That indicates below normal water temperatures. So we still got that going on, La Nina across the eastern and central equatorial Pacific areas, and then north of that, generally north of 30 degrees north latitude, you see these brighter oranges. This indicates above normal water temperatures off the coast of Japan, off of just south of the Aleutians in the north central Pacific, as well as working its way a little bit over towards the Gulf of Alaska. One thing you do notice that's different, if you take a look at my previous teleconnections video, which was a few weeks ago, now we're starting to see blue coloring here closer to Alaska there, and that's due to those storm systems moving through and really mixing up the water. And that water, due to the wind energy, that wind really kicking up the waves, that tends to redistribute the heat and bring cooler water up from the subsurface. So we are seeing a cooling effect here just off the coast, the south side of Alaska in general. And then we see this above normal water again off of Nova Scotia, right on down off New England coast as well. And you can see this brighter orange shading here. So real interesting stuff here on tonight's or today's sea surface temperature anomalies for the 18th of November. Looking at the latest La Nina update, generally showing where we're at right now. This is courtesy of Levi Cohen on tropicaltidbits.com. And you can see, generally since late October, we had a drop off in those water temperatures in the Nino 3.4 region. And then we had a little bit of a climb, and then we dropped back down to around -1 or 1 degree Celsius below normal water temps in the Nino 3.4 region. And now we're kind of holding steady at around a -1. I know the value here is -1.014 degrees Celsius below normal, but in general, we're sitting on that lower end of the moderate La Nina right now. What is moderate La Nina? Here it is. Any temperature departure in the water temperatures in that Nino 3.4 region between 1 to 1.4 degrees Celsius. And we're sitting right at 1. So, we're literally at the lower end of a moderate La Nina if you want to get technical in the classification. Here is the Nino 3.4 region. Here's all the Nino regions. You have Nino 4 further west, and then you have Nino 3.4, and then you have Nino 3 over here, and then you have Nino 1.2. So here's the Nino 3.4 region if you're interested as far as the latitude and longitude box, the coordinates. Here is the latest La Nina forecast, courtesy of NOAA's Climate Prediction Center. The vertical blue bars indicate La Nina conditions, and then the gray bar indicates neutral conditions, and so neutral. And then this red line, this red vertical bar indicates El Nino conditions. So, generally looking at the months here on the x-axis down here at the bottom. So we're sitting in November, December, and January, and here's our tall blue bar that indicates La Nina. Over here on the y-axis, you see the percentages from 0 to 100% for the chance or probability of these conditions occurring. So November, December, and January, we're above 90% La Nina probability, which matches up well with what's going on right now. As we move into December, January, and February, the chances of La Nina drop off to about 77 or 76% for December, January, February. And then as we get into January, February, and March, the La Nina probability starts to really drop off rapidly down to just under 60%. And then definitely by February, March, and April, we should see some waning effects of the La Nina. Could be down to 40% probability. And look what just surpassed it, this gray bar. There's a higher probability of ENSO neutral conditions in the February, March, April time period. And then as we continue towards the summer season, the late spring and summer next year, you notice this little red bar starting to grow taller, right? That's your El Nino probability. So it's starting to increase as we get into June, July, and August next year, 2023. Here are the different models that are produced by IRI, the International Research Institute for Climate and Society. This was updated on the 19th of October. Generally showing a trend in the majority of the models. You notice how the trend is going up closer to the solid black line here in the middle. That is your general, zero departure from normal sea surface temperatures. And so you kind of see what's going on here with this line. You're getting warming as you get into February, March, April specifically, and then March, April, May into the spring next year. So overall, latest update from the Climate Prediction Center, a 76% chance of La Nina for December through February, gradual weakening towards the end of the winter season, heading into spring. Now let's take a look at some of the teleconnections. Let's take a look at the Arctic Oscillation first. And just as a review, negative Arctic Oscillation is over here on the left, and then positive Arctic Oscillation on the right. Just showing you the differences in the circulation patterns with a negative AO. This is what you have. You have, a much more amplified polar front jet stream. You get a huge upper level ridge into the Gulf of Alaska. And then you get this cold air on the front side of that ridge. It just spills straight from the polar areas southward into the United States. And so you get this fairly strong low in the vicinity of Hudson Bay. And on the backside of that low, you just keep seeing these little disturbances rotate around the backside of the low. And then you get a lot of cold air in the eastern U.S. with a negative AO. If you look at a positive AO here on the right, we got a difference here. Number one, we got a much stronger stratospheric polar vortex. And so most of the most frigid air temperatures stay locked up over the North Pole area. And you notice too, we have lower pressure, higher latitudes when we're dealing with a positive Arctic oscillation. And then so we generally have a west to east jet stream, a highly zonal jet is what we call it. And so you generally have mild conditions across the United States with a positive AO. So let's take a look. Looking at the European deterministic AO forecast, generally this is where we're starting today, the 18th of November. You notice how we're going to go slightly positive, and then we dropped off to negative territory after the 27th of November. The European EPS AO 50 per term member forecast, this green line is that average, the general average of the ensemble of all the model members, showing a general neutral condition through 26 November, and then a drop off of the AO to negative territory. Looking at the European EPS AO 50 per term members, now this one goes all the way out to the new year, the 1st of January. Again, this green line represents the ensemble mean, or the average of all the model members, showing a neutral condition of the AO through 26 November, then dropping negative through the 13th of December, and then going slightly positive after that. Looking at the GFS deterministic forecast AO, here's what you got. You got a little bit of a bump up to the positive side, but then things drop off negative. Neutral through 21 November, really, if you want to average this out, and then negative before transitioning back towards neutral around the 1st of December. Then finally, the NOAA GEFS version 12 AO 30 per term member forecast. The green lines are ensemble mean, showing again neutral conditions of the AO through 21 November, then dropping off significantly negative actually on the GFS ensemble. Now let's take a look at the North Atlantic oscillation forecast. Here's your big differences between a positive NAO phase and a negative NAO phase. The big things to look at here are, the jet stream is more zonal west to east. With a positive NAO phase, and here's your typical colder or warmer than normal areas. And then with a negative NAO phase here on the right, you're seeing more of that Greenland blocking, or the North Atlantic blocking, that ridge. And so you get, more of a meridional jet stream, that solid dark line here, the arrow that represents that jet stream, the polar front jet. So you get much deeper troughs along the U.S. East Coast, for example, and then some additional troughing, cold and dry conditions across the northern European area. Here's the forecast, European deterministic, North Atlantic oscillation forecast showing neutral conditions through 26 November, then dropping off to negative territory. The European EPS NAO 50 per term member forecast generally showing a neutral condition to the NAO through the 27th of November before dropping slightly negative. The European EPS NAO 50 per term member forecast showing near neutral conditions all the way out through about the 1st of December. And then it's going to drop negative through mid-December, through about the 15th of December, and then become neutral again. And then the GFS deterministic NAO forecast showing neutral conditions right on through the 22nd of November. If you average this out here, the ups and the downs, generally neutral conditions through 22 November, and then becoming negative after that. And then finally, the NOAA GEFS V12 NAO 30 per term member forecast showing near neutral conditions through the 22nd of November, eventually going negative after that. Looking at the Pacific North American, or PNA forecast, here's the difference between a positive PNA on the bottom left diagram and a negative PNA on the bottom right. Big differences here, showing here in this riding positive PNA, you increase your chances of below normal temperatures across the eastern U.S., with our region being on the western fringes of below normal temperature area. Typically what you get with a positive PNA pattern is you get a ridge out western U.S. and a trough in the eastern U.S. With a negative PNA, we flip that pattern. So now we have a trough in the western U.S. and a ridge in the east with a negative PNA, and that increases the chances for above normal temperatures across the eastern U.S. in a negative PNA situation, but colder temperatures over the western U.S. Here's the forecast. European PNA forecast, generally showing a positive PNA for the majority of the period. The European EPS PNA 50 perturb member forecast showing positive PNA right on through the 28th of November before it drops off to the negative. See this green line there, that ensemble mean, the average of all the model members of the ensemble system, the 50 of those members, and this is their mean, going negative. European EPS PNA 50 perturb members going all the way out to the new year, 1 January, showing a positive PNA through 27 November. But then look at this, the European EPS showing a negative PNA pretty much all the way from 1 December to 1 January. The GFS deterministic PNA forecast showing positive PNA right on through the 28th of November, becoming negative. And then the NOAA GEFS V12 PNA 30 perturb member forecast showing a positive PNA right on through the 27th of November before transitioning again to negative territory. And then finally, we look at the Eastern Pacific Oscillation EPO forecast. And boy, this has been a player lately. We've had a sharply negative EPO. And look at what you get with a negative EPO here on the left. You get a huge upper level ridge into the Gulf of Alaska. You get the jet stream with this huge ridge configuration even north of Alaska, right on up into the higher Arctic area. And then you get a downstream deep trough, and this is exactly what we're seeing right now across the United States. We got these Arctic highs that are just basically transiting down from the high north down to the United States, and the freezer door is basically open with a negative EPO. On the other hand, if you have a positive EPO, we now have that upper level ridge in the Gulf of Alaska being replaced by a stronger Aleutian low, an area of low pressure in the Gulf of Alaska. What that tends to do on the front side of that low there in the Gulf of Alaska, it tends to increase the heights downstream from it, from that trough, and you get milder Pacific air, more of a west to east polar front jet stream. So you got mild conditions, Pacific air from coast to coast. Look how mild it is across the southern U.S. and all the way up into most of the United States, the Ohio River, the Mid-Atlantic, with a positive EPO. Let's take a look at the forecast. European deterministic EPO showing a sharply negative tendency right now, and it's on the climb, transitioning to near neutral conditions if you average things out here at the end of this run, right on through the 28th of November. European EPS, 50 perturb members, showing a sharply negative tendency of the EPO, then transitioning to near neutral conditions pretty much after the 25th of November. A little bit slightly negative here at the end of November, but then it kind of recovers. European EPO, 50 perturb member forecast all the way out through 1 January, showing that sharply negative tendency of the EPO climbing to near neutral conditions from 1 December all the way out to 1 January. GFS deterministic EPO forecast shows a sharply negative tendency, just like the other models, climbing and rising to near neutral conditions, eventually becoming positive, according to the GFS deterministic, in the later parts of November and early December. And then finally, the GEFS V12 EPO forecast, sharply negative EPO becoming near neutral for the majority of the period. A little bit of a slight dip there into the negative territory, 27th to 28th of November. But in general, we become more of a neutral trend for the EPO. Now let's take a look at a couple other things here in the future. I'm going to talk about the stratospheric polar vortex forecast. We're going to look at GFS, we're going to look at the European model, then we're going to look at the GEFS, the Ensemble Forecasting System, the GFS. So initially here on the left, this diagram, I'm showing a stretched out or elongated vortex for today. These white lines represent height contours, and you notice how elongated these white solid lines look. That is indicative of a weaker, stretched out, elongated polar vortex in the stratosphere. And then next Friday, I want to show you a snapshot of what things look like next Friday. This would be the 25th of November, the day after Thanksgiving, showing two circular areas here. Like, so you see one lobe here, and then potentially another lobe over in this area, over towards, these maps are hard to read sometimes, but generally over towards Europe. So bottom line with the stratospheric polar vortex, the forecast from the present time now to next Friday, we still see that elongated or stretched out appearance of the vortex. Looking at the European polar vortex forecast, again, you see the stretched out nature. So instead of the white solid lines on the GFS, we have dark solid lines, which represent those height contours. And what we're looking at here is the geopotential height and the anomalies in meters. So whenever you see these orange coloring, that's indicative of higher than normal heights at the 50 hectopascal or 50 millibar level in the atmosphere. Generally, you see this stretched out look according to these solid dark black lines, right? See that like stretched out, elongated appearance? And so you're seeing lower, this would be anomalously lower pressure at that level down into southeastern Canada, extending down to the eastern US, and then you have above normal pressures at 50 hectopascals over Alaska right now, which makes a lot of sense being that we have that huge upper level ridge as a reflection of the troposphere. Look at the forecast for next Friday, the 25th of November. Wow, this whole lobe here, the polar vortex, is really interesting. That purple coloring indicating anomalously low heights over southeastern Canada. And you still see the stretched out appearance of the vortex on the European forecast, right on through next Friday, the 25th of November. Now, this model only goes out to, this is 168 hours out, but in general, the European model goes out to about 240 hours or 10 days. Here's the GFS ensemble forecasting system, the GEFS polar vortex forecast. And again, the orange coloring indicating above, now in this case, we're looking at temperatures, the ensemble mean temperatures. So if you see orange coloring, that indicates above normal temperatures at the, let's see, this is 10 hectopascal level, or 10 millibar level, well above the ground. And so orangish coloring is above normal temperatures, and green and blue colors below normal temperatures. So for today, we have, some warmer temperatures over on the northern European, northern Russian side. Really, it's northern Russian side here, actually. And then you have colder than normal temperatures in the stratosphere over Canada. And again, it's really hard to see. The dashed lines represent the height contour, or no, those are the isotherms rather, but the elongation of these isotherms is there. And then over here on the far right, we're showing the forecast at 10 hectopascal level, the temperatures. It looks to me like, things start to get a little bit stronger with the polar vortex. We still have some warming that's occurring in the stratosphere, generally on just the northwest and the main core of the polar vortex. So overall, the GEFS is indicating a strengthening polar vortex late November and early December. Here are some of the latest, looking at the ensemble forecast at 500 millibars, the height anomalies. Purple, green indicating below normal heights associated with troughs. Orange coloring indicating above normal heights associated with ridges. Troughs generally have colder temperatures, ridges warmer temperatures. Troughs generally have unsettled weather conditions, ridges dry weather conditions, okay? So right now, this is today in the upper left, and you can, or actually no, this is the forecast for this Sunday the 20th of November, and you can just see how this trough is set up across southeastern Canada, very cold temperatures associated with it. Meanwhile, that upper level ridge is starting to break down or flatten a little bit, weaken there off the west coast of Canada. The forecast here, according to the European EPS for Tuesday morning, the 22nd of November, showing that main core or lobe of the polar vortex generally moving off to the northeast. So now we're starting to get a flat, more modifying temperature regime across the United States all the way to the East Coast by Tuesday morning, the 22nd of November, more zonal west to east jet stream. Bottom left is a forecast according to the European EPS. This is for next Saturday, the 26th of November, showing a reestablishment of some troughing along the east coast of the United States, and then a little bit of a buildup of a ridge there over the Intermountain West up into south central Canada. And then bottom right here shows the more further out in time 500 millibar height anomaly forecast for 29 November, and generally showing troughing now moving into the western U.S. And you notice the absence of the ridging here now, right? It's not really that strong. You do have higher pressures or higher heights, but not nearly as high as what they once were. And so you generally have a west-east regime of air across the central Rockies, central U.S. to the east coast. So a general average temperature regime by the 29th of November. Looking at the GFS ensemble forecasting system, very similar for this Sunday, just extremely cold across the eastern U.S. for Sunday. We're talking January level temperatures. And then out west here along the west coast of Canada, you have height rises, ridge axis, upper level ridge of 500 millibars. The forecast for next Tuesday, or this upcoming Tuesday, the 22nd of November 2022, again, that zonal west-east flow is established. The core of the coldest air and the lowest heights moves off to the northeast. Forecast the GEFS model here at the bottom left for Saturday, the 26th of November, showing again that reestablishment of troughing next weekend across the eastern U.S. with this ridging. Now you will notice on the European EPS, the Ensemble Prediction System, the European, that ridge is stronger than on the GEFS. It's a little bit flatter look here to the GEFS as compared to that EPS European Ensemble. And then finally, the GEFS forecast for the 29th of November, showing some cooler than normal temperatures, lower heights along the east coast, also along the west coast, immediate west coast, and in the middle you have some milder temperatures and a bit higher heights. Looking further down the road for the longer range ensembles, we'll look at the European EPS, the Ensemble Prediction System. 1 December, this is from the 00Z run on the 18th of November. So we could be looking at a potential pattern change yet again, heading into early December. This is 1 December on the left, and this is 2 December on the right. And if one thing you notice out of here is, the orange coloring in the eastern U.S. and the blue coloring in the western U.S., this orange coloring indicating higher heights, which generally correlates to milder temperatures. Blue coloring, lower heights, usually equates to lower temperatures. So we could be looking at a troughing situation in the western U.S. as we enter December, and more of a higher heights, a weak ridge across the eastern U.S. As we head into the new month. Something to keep an eye on. So here are my final thoughts for tonight's video. The MJO is currently working its way into phase 6, forecasted to go to 7. That gradual transitioning potentially to the null phase by early December. And so initially, MJO phase 6 and 7, maybe near normal temperatures to slightly above normal temperatures across the eastern U.S. The La Nina conditions continue, as I showed earlier, across the equatorial eastern and central Pacific. We're down to a 1.01 degrees Celsius below normal water temperature in the Nino 3.4 region. And La Nina generally favors ridging and milder temperatures across the southeastern U.S. and the mid-Atlantic. Now that's just looking at La Nina alone, right? So I'm not factoring any combinations of other teleconnections with La Nina there. I'm just saying with La Nina alone. Sea surface temperature anomalies, we have warmer than normal water across the North Pacific and the North Atlantic, specifically north of 30 degrees latitude. And we do see a little bit of a cooling trend in the water temperatures in the Gulf of Alaska as well as the North Atlantic, specifically southwest of Greenland. That will generally favor, that kind of sea surface temperature anomaly configuration favors near normal to mild temps across the eastern U.S. And it may result in time with a more energetic west to east jet stream. That Pacific jet may really get cranking if you get a strong north-south water temperature gradient established. Models are indicating neutral transitioning to negative AO phase. Now this is interesting to me, that going neutral to negative Arctic oscillation late November, early December. Neutral conditions on the AO favors near normal temps across the eastern U.S., but negative phased AO favors below normal temps across the eastern U.S. with a more meridional jet stream, more north to south orientation of the jet stream, vice east to west to east. So that'll be interesting to watch, as well as the NAO, North Atlantic Oscillation, similar, neutral to negative NAO phase, late November into early December. Now the neutral phase of the NAO, near normal temps across the eastern U.S., similar to AO. The negative phase of NAO favors below normal temps across the eastern U.S. And you usually get more of a blocking pattern up into the North Atlantic with a negative NAO, a more meridional jet stream. And then finally, the last slide in tonight's presentation, the models are indicating a positive P&A phase trending negative by early December. Below normal heights and troughing and cold temps over the eastern U.S. occur with a positive P&A phase, with higher than normal heights and ridging and mild temps across the western U.S. We're looking at that positive phase of the P&A in the short term, but then there could be a pattern reversal, which is favored by early December with milder temps across the eastern U.S. and those cooler temps and more unsettled precipitation regime out west. Now, models are also indicating a sharply negative EPO phase through 25 November, and then that's going to become neutral in early December. And a sharply negative phase, as we're seeing right now, that favors a meridional polar front jet with extremely cold temperatures across the eastern U.S. with that sharply negative EPO. A neutral EPO, on the other hand, favors near normal, near average temps across the eastern U.S. And then finally, we took a look in tonight's presentation on the stratospheric polar vortex forecast in early December. What we're looking at is, I hate to say it, but if you like winter weather, I get it. Some of the modeling has indicated some stretching still going on into early December of the stratospheric polar vortex. But I am seeing some more trends towards a stronger polar vortex as we head into early December. Now, this is strictly based off of the model runs I looked at earlier today on the 18th of November. Things obviously can change, but right now that's what I'm seeing as we head into early December, a strengthening polar vortex. That would favor milder temperatures across the eastern U.S. and the mid-latitudes as a whole. So that's something to keep a close eye on, the tendencies of the forecast in the future for that polar vortex. Overall assessment, we looked at everything here, okay? We took into account the MJO, the La Nina, the sea surface temperature anomaly configuration in both the Pacific and the Atlantic, North Atlantic. We also looked at the AO phase and forecast, the NAO phase, the forecast for that, the PNA, the EPO, and then the strength of the vortex, the polar vortex. Taking all this into account, we are seeing an extremely cold pattern, obviously, in the current time across the eastern U.S. this weekend. We're going to see temperature anomalies on the order of 15 to 20 degrees Fahrenheit below normal for many locations east of the Mississippi River. Troughing will continue for the most part across the east as we head into late November. Now, I am seeing some changes next week, as we get into Tuesday, Wednesday next week. Right before Thanksgiving holiday, we're looking at a more return to more zonal conditions. The jet stream, that major trough over southeast Canada into the New England area, it's going to lift out to the northeast. So we could be looking at a milder regime as we head into Tuesday and Wednesday next week, and even into Thursday, and even Thanksgiving Day itself. And then, the models are really having a hard time deciphering where a potential storm may develop late next week in the Friday time period, the 25th of November, as well as Saturday, the 26th of November. The models are having a difficult time figuring that out. So we could be overall looking at a pattern change with the trough in the west and the ridge in the east, per the latest ensemble model guidance, okay? And that would occur in early December, where we get the trough in the western U.S. and some weak ridging in the eastern U.S. The negative AO, negative NAO combination, plus a transition to milder MJO phases 6 and 7, along with a strengthening stratospheric polar vortex, they all point to milder temperatures across the eastern U.S., at least initially to start the month of December. Outside of that the Ural mountain area and basically back towards Greenland, there is an absence of significant high latitude blocking and huge upper level ridges across the northern hemisphere. Outside of these areas, really, that Alaskan ridge is finally breaking down. You just don't see that kind of strength of a ridge poking back up into Alaska anytime soon. So overall, that's what we're looking at. This is the overall assessment. It'll be interesting to see how all these teleconnections kind of tie in with each other and what the end result will be. All right, that wraps the video up tonight. It's a little bit late. It's getting late. So I wanted to get this video out here to everybody. So I hope you enjoyed the Teleconnections discussion. There's a lot of exciting things ahead. I love this time of year. Late November, December. You're heading toward the winter solstice in about just under a month from now. And it's just really exciting time if you like, dynamic weather and these changes. All right, that wraps things up. Until next time, everybody, take care and God bless.